When material takes control. Hello, my name is Sharan Elran. I am a designer, educator, and researcher. In all of these capacities, I'm exploring new ways to combine digital fabrication and computation with traditional craft. My PhD thesis, which I'm writing at the School of Computer Science and Engineering at the Hebrew University of Jerusalem, focuses on the possibilities of personal expression in the context of highly automated environments and the creative agency of digital machines.
Hi, my name is Barak Pellman, and I'm an architect, educator, and a researcher at Bezalel Academy of Art and Design in Jerusalem, where I'm also the director of the Hybrid Pedagogy Lab, a new research group focusing on design education and pedagogy. I'm a faculty member at the Architectural School, where I lead a unit dealing with the role of materials and technology in architectural design. My PhD thesis, which I'm writing at the School of Computer Science and Engineering at the Hebrew University in Jerusalem, focuses on the role of contemporary craft in architectural education.
Most contemporary architecture programs use a pedagogical model where students construct their design knowledge by engaging in an architectural project. However, due to the size and complexities of the physical environments they study, students develop their design knowledge primarily by using representations of the material world, rather than the real thing. Therefore, the learning opportunities afforded by the experience of materials are often overlooked. In this presentation, we will present an architecture design build course that uses materials as the primary agents for learning architectural design. Materials are active and performative and do not simply react to human intentions and forces. They invoke sensations, they mediate interactions, they change human intentions and induce emotions. Therefore, interaction with material can lead to new ideas, stimulate curiosity and learning, and lead to new understanding. Building materials are social and cultural constructs. They are produced through the complex relationship of legislation, regulation, production techniques, language, and usage. In return, they create possibilities and limitations, ways of working, and specific experiential conditions. Our course aims to explore the affordance of materials in architectural education setting. In order to do that, we introduced the construction materials at the very start of the course, together with a very vague programmatic brief. In this case, the bamboo pavilion, the brief was to design an entrance pavilion for the architectural department at Bezalel. So if in traditional architectural design studios, students will first design the shapes and then will introduce materials, here we start with the materials and allow them to dictate the shape and the design. In the first run of the course, we used bamboos.
So, as a material that comes in shapes of a pole, the bamboo invited structural studies that based on such concepts as tensegrity, reciprocal structures, and hyperboloid and alike. Detailing the joints were done while prototyping, and here we see the students engage with the conversation of a craftsman that is an expert in bamboo technologies, and testing the structural properties on site, and also in simulation techniques. Since each pole is a bit different in shape and also change along its length, no single and standard joint could be designed. Therefore, a 3D printed joints were specifically designed for each place it was needed. The branch pavilion. The second time we ran the course, we contacted Jerusalem Park Department and asked them to give us branches from their tree pruning activities. Cities in Israel generates approximately 500,000 tons of pruned branches each year, which usually are chipped and used either for compost production or soil cover in an expensive downcycling processes. Using these branches in our courses would potentially retain these trees back to the city, where they could provide shade again and hereby regain social and cultural meaning. We collected some 100 branches from multiple species with various shapes and properties. Now, the variety of shapes was so large that the student needed to learn scanning technologies in order to be able to represent the material. Each branch has got its own individual passport. Form finding were done using traditional 1-to-10 physical models, but also the digital optimization techniques between maximum shading potential and minimal structural load were used using digital technologies and software. Here also, as it was the case in the bamboo pavilion, since each branch was so different in shape, no single standard joint could be designed. Therefore, the students had to develop a parametric joinery system that would change automatically according to the diameter of the specific place in the branch. And since each joint was different, we trained a robotic arm to carry the task. And here you see the spring, or the one case that was specifically complex joinery system where it was very difficult to train a human, even expert, in carving this joint, but it was very easy to train the robotic arm to do that. These joints were then tested in order to validate their strength, and they calibrated to the calculated forces, adding now new experiential knowledge to the theoretical numbers generated by the software. And this was the outcome of that stage. We see the spring joint, and we see the continual joint of the arch. That was the final pavilion.
The woven pavilion. So the third and last round so far of the course, for the we used the primary material was 4mm thick plywood. And the students were inspired by a kerfing technique that by programming and cutting specific patterns can induce new properties to the material. Kerfing, also known as a living hinge, allowed manipulating the plywood into complex surfaces with double curvature. Different patterns weaken the material in different ways, allowing a vast range of shapes and manipulations. The students then try to incorporate these properties into their overall design concept. The final design was a set of 3 net-like structures woven together to perform as one system. As in previous projects, the design process included fabrication of a 1-to-1 sample joint and physical testing of their structural properties. The students tested different kerfing patterns in an effort to optimize production limitations, structural properties, and aesthetic preferences. The entire structure then was simulated in software to assess the overall systemic structural properties. When we then moved into building the actual structure in scale, and while the students were building the structure, they experienced directly the multiple gaps between the virtual and the physical, between what was represented and what was materialized. They had to resolve the real material situations and issues as they were encountering them. The final design was the outcome of the complex interplay between material properties and opportunities and the aesthetic sensibilities of a large number of individuals, and an exciting exploration of the possibilities of the kerfing technique in architectural scale.
In his seminal work, Educating the Reflecting Practitioner, Donald Schoen describes the role of the architectural educator as the figure who designs the architectural brief and engage with the students in the process of reflection, and generally act as the sole gatekeeper of architectural education. Here we suggest a pedagogy that gives material a stronger voice and allow them to act as learning agents. They created learning opportunities in direct and indirect ways. They reframed design problems and afforded ample learning opportunities for specific structural schemes, joinery techniques, management tactics, and representation and fabrication technologies. Material engagement also affected the students' learning journeys. As one learning subject led to another, and new design decisions created new learning challenges. Materials not only created learning opportunities, but also contributed to learning by eliciting curiosities and motivations, and were able to charge environmental values to design intentions. Thank you very much for listening to these presentations, and please contact us should you have any questions or like us to elaborate more on the subject presented.